Good day, viewers. You are welcome back to my channel. As you already know, my name still remains Israel Gwai. In your comment section, many of you have been asking me to teach you more calculations in practical chemistry, actually under the topic titration. So, I want to go into it. But before I start, I want to appreciate all of you that have been subscribing to my channel and also viewers that have been viewing my channel. And those of you that are also spreading it, you are God bless you all and God bless you richly. So, let's get started. Now, the first calculation given before us today is solution A contains triazonitrate acid of unknown concentration. Solution B contains 6.90 grams of potassium triazocarbonate 4 per dm cube. So the titration has already been done, and that's the practical work like we did in our first video. If you turn back to the first video, you see the process of carrying out a perfect calculation that is accepted by all the examination bodies and the precautions you must take. So it has been done, and the result they have is 16.00 cm cube. That's the volume of the acid used. So say calculate the concentration of potassium triazocarbonate 4 solution in mole per dm cube. B, number of potassium ions in 1 dm cube of solution. C, number of potassium ions in 100 cm cube of solution. D, mass of potassium ions in 1 dm cube. And they are giving all the things that we need to carry out this calculation. So to start, we write solution. First of all, write the equation out. Most often they give us the equation, but if they don't give you, you have to derive your own. So this is the equation like what they've already given us here. So the first thing you are going to do is to write the mole ratio, because that's where the math starts. Mole ratio. Acid to base, as we already know, this acid is base 2 to 1. That's where they start your marking. So having done that, you now consider the method you are going to use. If you look at it, you have only concentration in gram per dm cube. This is dm cube, and you don't have the mole. You don't have any value for acid. And moreover, to carry out this calculation, okay, to CO3, that's concentration of this in mole per dm cube, I have to use this formula. Concentration, that's A. Molar concentration. You can also write concentration in mole per day. It's all the same thing. K2CO3 equals mass concentration over molar mass. Molar mass is K2CO3. So this one now gives us, they're already giving us the mass concentration at 6.990 gram over molar mass 39. We're already given that, you should know that by now. 39 times 2 plus 12 plus 16 times 3. This one is 6.90 gram over, remember this gram per mole. So automatically we get there, we talk about it. So let's carry out this calculation and see. So you have 6.9. 6. Before we do that, let's do the one at the bottom. 39 times 2 gives 78. 78 plus 12 plus 48 gives 6.90 gram. This gram, this times, it now becomes mole over gram. Because it's dividing it, so it has to be inverse. So go up. 78 plus 12 plus 48. You have 138 over 138 over gram times mole. Gram will cancel gram. So it now becomes 6.9 divided by 138. You have 0.05 mole. As you've been instructed before in our previous video, in examination body you are not allowed to use this. Therefore, you must make it 3 significant figures. It becomes 0.0500 mole per dm cube. So this is the first calculation, which is this. That's the molar concentration we already calculated. The next one is number of potassium ions. Once you have number, it means you must use the Avogadro's number, Avogadro constant. So, but if you look at the potassium ion, this potassium, say number of potassium ions we want DMQ. So this potassium, so we now say B, K2CO3 will dissociate to 2K plus CO3 2 minus. You see, this is 1 mole here, this is 2 moles. Those are the only 2 things we need. We now say if 1 mole of K2CO3 gave 2 moles of K plus, therefore let's go up. If 1 mole give that, therefore this mole 0.05 moles of K2CO3 will give you 2 times 0.05 mole, just using the mole ratio method. So it now gives you times 2, you have 0.1 mole for now. But 1 mole is equivalent to 6.02 times 10 to the power 23, which is the ions there according to Avogadro's number or constant. Therefore, number of potassium ion will be 0.1 times 6.02 times 10 to the power 23. So if you carry out this, it will now be 1.0 times 10 to the power 22 ions. That's why you shift it 1. Don't shift it 1. Is it 1.0? 6.0, right? But let us use 6.0 times 10 to the power 22 ions. 6.02 actually. So that's what we will get. Remember, it's supposed to be 0.06, but because we have shifted it 1 space, this one will not reduce. So that is that for the second question. Then the third question. For the third question, it says number of potassium ions in 100 cm cube. Remember, this one is in DMQ. You say 1000 cm cube will give you 6.02 times 10 to the power 22 ions. Then 100 cm cube give you x. Cross by x will now give you 6.02 times 10 to the power 22 times 100 cm cube, this ion, over 1000 cm cube. Double 0 will cancel double 0. Then if you do this, this one gives you 0.602 times 10 to the power 22. So you shift it again, gives you 6.02 times 10 to the power 21 ions. Then for the last one, mass of potassium ions. See from the dissociation, 2K K2CO3 gives you 2K plus CO3 2 minus. So it's still the same relation, 1 mole, 2 moles. So 0.05 moles will give you 2 times 0.05 moles. But remember, we are dealing with the mass this time. Mass of bed, atomic mass of potassium is 39. Therefore, mass of potassium ion will now be 2 times 0.05 times 39 gives you 2 times 0.05 times 39 give you 3.9. So this is how you carry out calculations involving ions or no other number of ions or mass of ions. Thank you very much for watching. The next video, I'm going to carry out calculations on how to calculate volume of carbon dioxide and so many others, so that you're really satisfied with watching this channel. God bless you. Please don't forget to share this channel and also subscribe. God bless you.